Hi friends, this is Dr. E. Ramanjana Reddy and you are watching Dr. Reddy's Chemistry World. Students, if you are watching first time, please subscribe and share our channel to your friends and your relatives also. Okay. Now today I am going to discuss about mole concept problem. This video particularly helpful to the students who are going to write intermediate board exams. Okay. So in board exams, generally they will ask you one problem which is based on mole concept. In order to solve those problems, first you should know some formulas. In that, one of the formula is number of moles. So number of moles is equal to weight by molecular weight. They will ask you problems like this. Calculate number of moles of glucose and whose weight is 540 grams. See here, weight is given, molecular weight is not given, and they are going to ask you find out number of moles. So this molecular weight you are going to calculate with the help of molecular formula. What is the molecular formula of glucose? C6H12O6. So from this 6 carbon atoms are there. Each carbon atom atomic weight is 12. 6 into 12 plus 12 hydrogen atoms are there. Each hydrogen atom atomic weight is how much? 1. So 12 into 1 plus 6 oxygen atoms are there. Each oxygen atomic weight is 16. So 6 into 16, that is equal to 180 grams. So this is the molecular weight of glucose. So now N is equal to weight by molecular weight, that is equal to 540 is the given weight and molecular weight is the 180. So that will give you 3. Next formula is molarity is equal to number of moles of solute present in 1 liter of solution. Therefore, molarity capital M is equal to number of moles indicated with small n and volume of solution indicated with V. Volume of solution is in liters, that's why I wrote in brackets liter. Now I convert, suppose in problems, if the volume of solution is given in ml, if use this formula, M is equal to N by V, V is in ml, and you should multiply this formula with what? 1000. Suppose for example, 0.5 moles of NaOH dissolved in 250 ml of solution. Calculate the molarity of the solution. They will ask you like this. So here moles is given, volume of solution is given, and they are asking molarity of the solution. So molarity M is equal to N by V into 1000. I am using this formula because here the volume of solution is given in ml. Okay, that's why I use this formula. So N is 0.5 by volume is 250 and multiplied with 1000. Now 250 is 1, 250 is 4. So 0.5 into 4, 2 molar. Now coming to the next formula, that is molarity expansion formula. See, in the previous case we discussed molarity is equal to number of moles of solute present in 1 liter of solution. So if volume is given in ml, the formula is M is equal to N by V into 1000. So now where N is substituted with weight by molecular weight, now the molarity formula becomes like this. Molarity is equal to weight by molecular weight into 1 by V in liter when you substitute in this. Suppose N value substitute In this equation, now you will get this equation. So molarity is equal to weight by molecular weight into 1000 by V in ml. Okay. Now coming to the problem. 2 grams of NaOH dissolved in 100 ml of solution. Find its molarity. So here weight is given and volume is given in ml. That's why I use formula 5. Now molarity is equal to weight by molecular weight into 1000 by V in ml. So weight is 2 grams and molecular weight of NaOH is how much? 40 and 1000 by V. How much volume? 100 ml. So you will get 1 by 2, that is equal to 0.5. Next, normality. Normality is equal to weight by gram equivalent weight into 1 by V in liters. See, the difference between molarity and normality is, instead of molecular weight, here gram equivalent weight. This gram equivalent weight we are calculating with the help of this formula. Gram equivalent weight is equal to molecular weight by n factor. Okay, forgot about now that one. So suppose V is given in ml, normality formula is weight by gram equivalent weight in 1000 by V in ml. See, in problems they are asking like this. 9.8 grams of H2SO4 dissolved in 100 ml of solution, find its molarity and normality. See, here weight is given and volume is given in ml. So I should use these two formulas. So molarity is equal to weight by molecular weight into 1000 by V in ml. 9.8 is the weight. Molecular weight of sulfuric acid is 98 into 1000 by V. Volume of solution is given how much? 100. So 1000 by 100. So 90. So two zeros get cancelled. 9.8 into 10, 98 by 98, that is equal to 1 molar. Now coming to normality. Normality is equal to weight by gram equivalent weight into 1000 by V in ml. See, weight is 9.8. Gram equivalent weight I am calculating with this formula. So what is the molecular weight of sulfuric acid? 98 by n factor. What is the n factor for sulfuric acid? 2. So 98 by 2, that is equal to 49. So 9.8 by 49 into 1000 by 100. So two zeros get cancelled. 9.8 into 10, 98 by 49, that is equal to 2 normal. So what is the relationship between molarity and normality? Normality is equal to, this is the ninth formula. Normality is equal to molarity into n factor. Okay, you should know all these formulas, then only you can answer mole concept questions. Next problem based on chemical equations. See, here we are doing calculations based on chemical equations. So they are asking problems like this. What volume of CO2 is liberated at STP by heating 4 grams of calcium carbonate? So here calcium carbonate, which on heating gives calcium oxide and carbon dioxide. This you should know. This chemical equation you should know. After that, you should balance that chemical equation. Okay. So here the chemical equation is balanced and the coefficients of calcium carbonate is 1 and calcium oxide is 1 and carbon dioxide is 1. So from this chemical equation, 1 mole calcium carbonate will gives 1 mole carbon dioxide, which on heating, right? Yes. See here, calcium carbonate is given in weight and carbon dioxide is given in volumes. Means you are going to find in terms of volume. So this type of problems generally we called weight volume relationship calculations. See here, calcium carbonate is given in weight, right? So 1 mole calcium carbonate weight is equal to its molecular weight. What is the molecular weight of calcium carbonate? 100. So 1 mole calcium carbonate will be equal to 100 grams. So 100 grams of calcium carbonate. Now we are converting this one into liters because carbon dioxide they are asking in terms of volume. That's why I am converting this mole into volume. So 1 mole of any gas at STP conditions, it occupies 22.4 liters. Okay. So in problem, 4 grams of calcium carbonate which on heating gives how much volume of CO2, right? So 4 grams of calcium carbonate will give you question mark. Now we are finding X is equal to 22.4 into 4 by 100, that is equal to approximately 0.89 liter. Okay, this is called weight volume relationship problem. Weight volume relationship problem. The same problem they will ask you like this also. Instead of volume, suppose what weight of CO2 is liberated at STP by heating 4 grams of calcium carbonate. Then instead of 22.4 liters, here you should use 1 mole of CO2 weight is equal to its molecular weight, that is 44 grams. Now 4 grams of calcium carbonate will give you how much amount of CO2 means cross multiplication. So 44 into 4 by 100. So 4 ones, 4 25s means 44 by 25. So approximately, so 25 ones approximately 7. 1.7. This is grams. Okay. So this is called weight relationship problems. Okay, weight relationship problem.